Hey everyone, I'm Untitled, an 8th grader from John F. Kennedy Middle School. And in my last video I was discussing how I would start a whole prep for the SAT Math Level 2. And so here's the start of it. Today we're going to start off with the basic topic of a function. A function is a very brief term used in algebra, which not many people know all about. And it's probably also one of the most important things that's probably one of the most important questions that's going to come up in the SAT Math Level 2 test. So why don't we get started on what functions actually are before heading on into some problems. So a function, if I were to describe a function in some words, I would describe it as a process in which a set of input numbers is turned into a set of output numbers. Now, this is a very on-point definition because of the fact that everything about it is true. A function is basically when, if given an x value, there's always going to be a corresponding y value. And so that is kind of what this is saying. Now, one of the things you always have to keep in mind is that functions are, the input and output are considered variables, where the input is usually the x and the output is usually the y. And that's probably the main way you're going to see it, unless there are some exceptions when it comes to how the problem works. So, some important terms which you're going to need to know when talking about function is domain and range. Now, domain and range are some terms that are used quite frequently too, so they're really important to know. A domain is a set of input numbers, also known as x, and the range is obviously the opposite, the set of output numbers, y. And so, there are always those type of questions asking the domain of x, the domain of y. And usually that basically says, are there any exceptions? So if they're asking, let's say, what's the domain of x? They're basically asking, is there any x value which you can't have because of it being undefined, or just because maybe some questions have some other reasons on why there would be a reason why the domain or range wouldn't be all real numbers. And so the domain, the answer is usually all real numbers, but there are a few exceptions. Now, functions are part of the relations family. The relation is an association between two or more variables, obviously saying that because a function is talking about x's and y's, that's its two variables, so it is part of the relationship family. The graph of a function should always be drawn. Let's see, how do I say it? It should always be able to be drawn without taking your pen off the paper or pencil off the paper. But now here we come to the vertical line test. Now the vertical line test is something I've already done in a previous video. But just to show you again what it is, it's something to tell you whether your graph is a function or not a function. And the way you do that is, before getting on into this, one of the things you need to know is that each x value can only have one y value, meaning that, let's say, this value over here, it looks like it does have more than one y value, so therefore it is not a function, and I'll explain to you why. So basically, what the vertical line test is, okay, so here, I'm going to start a new little section, because the vertical line test is a very important test used for functions. Vertical line test. Now the vertical line test is a test done on graphs to see whether it is a function or not. And again, it's something I've already taught, and if you want to know it much better, you can go watch that video, which is somewhere on my channel. And so, basically the way you do the vertical line test is it's very self-explanatory. You kind of draw vertical lines all throughout your graph, and see if there is ever an x value where there are two y values corresponding. So let me give you guys an example. So if I'm doing this one, then I'm going to draw a bunch of vertical lines, okay? Okay, as simply said, vertical lines, as you just keep drawing vertical lines, you would see the majority of the graph only intersects each vertical line basically once. Except for this line over here. This line is kind of multiple places on that. But besides that one point, which is completely describing that it's not a function, by the way. So basically that's how the vertical line test works. And let's say that this point was in here, it would have basically been a function because each time there's a vertical line, it's only intersecting once with the graph. And that's how you know whether your graph is a function or not. If it intersects only once per vertical line, that means it is a function. Now, I'll be right back in a second with a few problems that we could do, and they'll be SAT type problems, which you can expect to get on the test. Hey guys, I'm back, and here I have two of our first problems for the video. And the first one here is, if we had a set of 3, 2, 4, 2, 3, 1, 7, 1, 2, 3, and we want it to be a function, which one would we have to remove from the set? So let me write all of these bigger so that we can, visualize our territory here. 4, 2, 3, 1, 7, 1, and 2, 3. And it's asking which one of these would we have to remove in order for it to be a proper function. Now basically, the only reason they would ask that is if there's a repeat of x values. In which case, in our case, there is. We have a 3 and a 3. So we have two x values of 3 with two different y values, which is basically stating the fact that it's not a function because there can only be one y value per x value. So our answer is pretty simply said. Since we have this 3 and 3 with two different y values, they are completely, this is completely not a function. But one thing to note is that if this were to be a 1, then this would have been a function, because then it would have just been a repeat of the value 3, 1. So the thing that we could remove from our set over here is either a 3, 2 or 3, 1, because either one of those would help satisfy the fact that this is a function. Second question, what values must be excluded from the domain of f of x equaling x plus 2, x minus 2? Now here we have our keyword which we were defining earlier in the video, where the domain is a set of inputs. In other words, x's. So basically it's asking what x values are not allowed over here, which will make it, let's say, undefined, because that's the only other thing that could happen. So I can already see that you can't put in the x value of 2 because it would make it 4 by 0. So if I were to put in the x value of 2, it would be 2 plus 2 by 2 minus 2, which would actually make it 4 by 0, which is undefined. And the same thing does not happen with positive 2. So basically the only thing that's not allowed here, or which is not allowed over here in our domain, is negative 2. Negative 2 is excluded from our domain. Now, those are our first two problems. I'll be back in just a second with our next two problems. Okay, so here are probably our last two problems for this topic of functions, and if there are any questions after that, you guys can comment down in the videos, and I can probably make an extra sub video on the same topic so you guys can understand whatever you guys don't understand. But here are our last two problems, and our problem, and this is probably one of the ones that are kind of common on the SAT. If g of x is equal to 3x plus 2 and f of x is equal to negative 2x, what is g of f of negative 2? Basically what this is saying is it kind of wants you to find whatever the value of f of negative 2 is first. So why don't we do that? So let's see, we have f of x over here, and we're trying to find it of negative 2. So basically we're going to do f of negative 2 is equal to negative 2 times negative 2, which in our case is equal to 4. Now what it wants us to do is after you find that value, you want to put it into g. So then you take our value g of x, and it's equal to 3x plus 2. Then what we're going to do is we're going to make g of 4, where we put that 4 in there, and it's going to be 3 times 4 plus 2, which in our case is going to be equal to 12 plus 2, which is going to equal to 14. And our 14 will be our final answer right there. Very simple type of problem, which should give you easy points on the SAT. But if you don't know it, it looks very complicated and is very difficult to try to understand. The next type of concept I'm going to try getting through in this video is the inverse of a function. Now the inverse of a function is also another very easy, simple concept. And so in this problem we have fx equals 9x plus 20. And what we want to do is we're going to convert f of x into y, because that's initially what it is. So it's going to be y is equal to 9x plus 20. Now what you do in inverse is you switch the x and y. So it's going to become x is equal to 9y plus 20, and then isolate y, and that'll be the inverse of your function. So over here then we're going to have 9y is equal to x minus 20. Y is equal to x minus 20 by 9. So in other words, if you want to write this in the terms of f of x, you could write f inverse of x is equal to x minus 20 by 9. So again, another very simple thing to know when it comes to functions is knowing how to find the inverse of them, and that's really how you do it. So I hope this video on functions helped you. This is one of the first topics I'm going to do on the SAT Prep Math Level 2, and I'm going to come up each week with multiple videos on SAT Math Level 2 Prep. So I hope this video was helpful. Go like and subscribe. Share this with your other friends who need SAT Prep, who need help with SAT Prep. And so I hope you guys liked the video. Please comment on anything you guys need, and thank you for watching.